Hello, hello. I am going to go over questions 221 and 222. I cannot wait to be done with this list. My goodness. Okay. So we're on the home stretch. It says in 2009, a survey of internet users said that the proportion of internet users 18 and older was 79% in the US. This was a long time ago. That was back in 2009. Now they believe it is much greater. They want to conduct a new study, which would be a 98% confidence interval. And they're looking to estimate the new percent as well as having a margin of error that they want no more than 2.5 percentage points. Assuming that at least 79% of people still use the internet, which of the following would be this sample size? All right, so looking at our formula sheet, we know that to calculate a confidence interval, it's the point estimate plus or minus the margin of error. Now the point estimate would be simply whatever we calculated as the percent. So maybe we think it's up to 90%, doesn't matter. We're going to try to measure that in the study. And then the margin of error would be our critical value times the standard deviation of the statistic. So in this example, I can go to table B and look up the critical value, zoom in, and this is a 98% confidence interval. So that's the critical value I need, 2.326. This is the number we use a lot, but this is the value we're needing for this problem, 2.326. So our critical value is 2.326 because we've been asked to do a 98% confidence. So glancing through here, we notice that this would round to 2.33, and so the confidence interval here are the only ones that match. So I'm going to go ahead and eliminate these two. Now they also said you want the the margin of error to be no greater than 2.5 percentage points. So ultimately they want this margin of error to be no greater than plus or minus 2.5 percentage points. So this is being limited to 2.5 percentage points, and these two had 2.25. So this was the only one left, so I actually know it has to be D. It can't be anything else. But I do want to address our other choices of 0.5 times 0.5. So the formula states P, 1 minus P over N, and take the square root of the whole thing is the standard deviation. And if it's the statistic and you don't know the population, you can use the sample. Now, in this setting, we don't know. We're going to, we knew what it was back in 2009. And when we calculate a margin of error in other questions, we want to use the most conservative. So if you don't know it all before you start an actual survey and you're trying to get your margin of error a specific number or limited no more than, if you know nothing about the survey, the most conservative would be to leave it at 50%. And so if you'd assume that people would flip a coin and only half would say yes and half would say no, that would be 0.5. 1 minus 0.5 would also be 0.5. And then you place it over the number of people you sample and you take the square root. And so that's what they're showing you. This was what we would do if we didn't know anything. But notice in this problem, we know that it is at least 79%. So we're still being conservative here by assuming it's 0.79 and then 1 minus 0.79 all over N and take the square root. Again, that's why D is the correct answer. Now let's take a look at 222. A manufacturer claims that A lasts longer than B. 9 of the batteries tested were independently tested, and the battery's life is shown. Provided the assumptions are met for inference, which of the following tests would be used to determine whether or not brand A lasts longer than B? So what they're asking us to think about here is H sub O. we assume that the average length of battery A is the same as B. Or we could have shown this, mu A minus mu B, that there is no difference between the two. They're the same or there is no difference between the two. Now our hunch is that mu A is something longer than mu B. And so notice, since we've made a commitment to a greater than or less than sign, this is going to be a one-sided test. If they would have left these words out, we would have been forced to do a two-sided. So we like one-sided, 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 and we're going to eliminate the choices of a two-sided. Now we're down to, is this a paired test, two-sample t-test, or a z-test? Well, a z would be if we were given the standard deviation of the population of A and the standard deviation of the population of B, and we were not given that. So that, not given. So last but not least, is this a matched pair or a two-sample? Now ultimately here, I believe it's a two-sample, and that does match our answer key. And the reason is because these were two different batteries, and they were competitors. And so matched pairs usually has something to do with if I used a sample from the same company, or if I used actually the same item, I just had a before and an after. And that's not the situation here. So I'm going to say it's not a paired test or not a matched paired test. Thank you for joining us.